Part 2 of Section 8 focuses on Cramer's rule itself. So we talked about determinants and how to evaluate them, and now we're going to look at the method for solving systems of equations that uses determinants. It's called Cramer's rule. Basically what happens, and looking at this slide all at once might be a little overwhelming, but we're going to break it down a bit. Notice that we have a system of equations here, two variables, x and y. And from that system of equations, we're going to create some matrices and evaluate their determinants. So to begin, I'm going to hide the top parts of these fractions, and we're just going to focus on the bottom. Notice that A, B, and C, D come from the coefficients on x and y in the original system. Okay, so we have ax plus by, and the second one we have cx plus dy. So we're just pulling the coefficients and putting those in the bottom, finding the determinants of those and putting them in the bottom of the fractions that give us x and y. For x in the top, notice that we have replaced a and c, which are the coefficients on x, with the constants in the equation. Okay, we've replaced them with e and f. So y we didn't touch, we left it alone. B and d are still there, but since we're solving for x, we replaced the x coefficients with the constants. Looking at the top for y, we see that we've done the same thing, only we've replaced b and d with the constants e and f. Okay, we didn't touch x. We left a and c in there, but we took the y coefficients out and replaced them with the constants. So finding the values of x and y now just come down to evaluating the determinants. It's important to note here, notice this last little statement, as long as the bottom does not equal 0. If the determinant of the coefficient matrix A, B, C, D equals 0, then we can't find a solution to this system. Our example number 4 is solving a it says 2 by 2 Cramer, solving a two-variable Cramer's rule problem, and so we'll switch over to the document camera to do that. In example number 4, we're going to solve this system of equations using Cramer's rule. And the key here is setting up your determinant fractions. Okay, that's really the big important step here. So we're gonna set up two fractions, one for x and one for y. In both of these, the bottoms are going to be the same. It's just going to be the coefficient matrix for the left-hand side of these equations. So 1, -4, 2, 3. Same thing over here, 1, -4, 2, 3. Now the top determinants will be different for x and y. In the x determinant, for the numerator, what I do is I take the x coefficients out and replace them with the constants. So this is 1, 13 for the x's, and then -4, 3 stays put for the y's. And then over here with the y numerator, now we're going to take the y's out and put 1 and 13 in, and then we'll leave the 1 and the 2 for the x. All right, so now this will be the time where I think it's pertinent to show you guys how to do determinants in the calculator with the matrix menu. So to save a little bit of time, I have already put in some of these matrices. This one is the denominator matrix. B is the numerator for x, and I put in C as the numerator for y. So you might want to go ahead and pause the video and type those in, and then you can resume the video and follow along. So in order to do determinants, what we do is we go to the matrix menu, over to math, and then the very first option is DET, that's determinant. So I think I'll evaluate matrix A first. Remember, matrix A is our denominator matrix. So this one was A for both. B was my x numerator, and C was my y numerator. So if I want to figure out the determinant of A, that's 11 according to my calculator. So whatever x equals, it's going to have a denominator of 11. And so will y. That looks like that's a really spaced out 11. I apologize for that, but that is an 11. Now we want to figure out the determinant of matrix B.
which is 55. So remember, b was the numerator for x, so x is 55 over 11, or just 5. And then I'll do the determinant of matrix C, which is 11. So y is 1. So our final answer here is the 0.51.
When we scale Cramer's rule up to a 3x3, three-variable system with 3x3 determinants, things really start to get kind of overwhelming. So again, I'm going to hide the numerators for a moment. Again, the bottoms, notice that all three of the denominator determinants are exactly the same. They're identical. They are the coefficients from the x, y's, and z's in the system up at the top. And then in each of the numerators, we're going to replace the variable that we're looking for with the constants from the system of equations. So in the x fraction here, we see that we don't have a, d, and g anymore. Those were the x coefficients in the first column. We've replaced them with j, k, and l, which are the constants. Okay, moving on to the second fraction, you see that j, k, and l now show up in the second column. Okay, that's where the y coefficients were. They've been replaced. And then when we look at z, j, k, and l is now in the third column because it's replaced the z coefficients. So the pattern is not terribly difficult itself. The problem with Cramer's rule is there are 4 different matrices that we have to evaluate determinants for. So from a practicality standpoint, Cramer's rule with more than 2 variables is kind of clunky. So we have an example here that we're going to work on the document camera, and we'll see how this works, how we lay out our matrices, and we'll also see that it's kind of a lot of work to type in 4 matrices into our calculators. But nevertheless, here's example number 5.
In example number 5, we are evaluating or trying to solve a 3-variable system using Cramer's rule. And for me, this is where Cramer's rule kind of breaks down, because we're going to have a whole bunch of matrices, and there's going to be a whole bunch of numbers on this paper. And for me, a 3-variable system is much easier to solve some of the other ways we've done them. But nevertheless, Cramer's rule is part of what we have to cover, so here we are. Each of my fractions gets a little smaller. That's nice. So remember, in the denominators of each of these, we're going to have just the coefficients from our system. So from the first equation, 1, 1, negative 1. Second equation, 3, negative 2, 1. Third equation, 1, 3, negative 2. And the other 2 denominators will be the same. All right, so now in the top, for x, we take the coefficients for x out and we replace them with the constants. Whoops, marked on my paper. So 6, negative 5, 14, and then 1, negative 2, 3, negative 1, 1, negative 2. All of that, all of these 2 columns stay the same. And then for y, we'll have 6, negative 5, 14 in the middle column, 1, 3, 1, negative 1, 1, negative 2. And then for z, we'll put 6, negative 5, and 14 in the third column. We'll have 1, 3, 1, 1, negative 2, 3 in the first and second columns. So again, this is probably where you should pause the video and go to your calculator and start punching some buttons, start putting these in. I have gone ahead and done that once again, so I've called this one A, the denominator is A, numerators B, C, and D. So we're gonna have, so our determinant for matrix A is negative 3. So for all of these, we're gonna have negative 3 in the bottom. And yes, I also checked each of my matrices to make sure they were typed correctly. I'm not doing that on the video for the sake of time, but I did carefully check all my matrices to make sure they were typed correctly. That is definitely something that you should do as well. All right, the determinant of matrix B, which is the top of X, is also -3. The determinant of matrix C, which is the numerator of Y, is -9. And the determinant of matrix D, which is the numerator for Z, is 6. So, simplifying each of these fractions, we get X is 1, we get Y is 3, and we get Z is -2. So there's our solution to that 3-variable system using Cramer's rule.
To wrap up section 8, we have some properties of determinants that are worth discussing. I'm not going to read every single one of these to you, but there's a couple of highlights here that I think are worth going over. Number 3 in particular, if any 2 rows or 2 columns are identical, then the determinant is going to be 0. So, kind of look for that if you're solving with a Cramer's rule, Cramer's rule technique. If you see a matrix that has identical rows or columns, then you know automatically that's 0, and that may save you some time, particularly if that determinant is in the bottom of a fraction. Another one I wanted to point out is number 5. We talked about inverses in section 7, so if you find the determinant of a matrix and then find the determinant of its inverse, those 2 determinants will be reciprocals of each other. So the other properties, definitely read through those, and if you have any questions on them, please let me know. We'll have a a Zoom meeting shortly where you guys will be able to ask questions about any of this stuff. So I look forward to talking to you then. Until then, your suggested homework is here. Tried to pick out problems that I thought would be beneficial, so I didn't do a lot of this to that odd. I picked out specific problems, so hopefully these will be beneficial to you, and I'll talk to you soon.